Okay, this in this problem you need to find the equivalent uniform annual expense over the entire 30-year period. Basically, there is a bridge, and in this bridge the expenses are $30,000 per year for the first 10 years. Okay, and then after that there are just two separate $80,000 expenditures in year 15 and 20. In year 15 means at the end of, at the end of the year, so we take the expenses at the end of the year. Okay, so let's draw it, the diagram, cash flow diagram. Okay, so to make it just a little bit clear, so starting from 0, so the annual expenses are $30,000. Okay, annual expenses are $30,000. So here you have the annual expenses. Okay, up to 10th year. Okay, 1, 2, 3, and up to 10 year continuing. So $30,000 each year up to the year 10. And then in the 15th year there is an expense of $80,000, and then in the 20th year there is an expense of 80,000. So this is 80,000. I can put it 80k, 80,000. And the useful life of the bridge is 30 years. So this is 30, this is 20, and this is 15. Okay, so we need to find the annual equivalent uniform annual cost, or EUAC. We have to find EUAC, equivalent uniform annual cost. Okay, equivalent uniform annual cost. Okay, or cost is the same as the expense, equivalent uniform annual expense. So basically we have to convert all the cash flow to their annual equivalent. So there are many approaches. So one of the approach is that first find the present value of all the cash flows. So present value of all the cash flows. So we have this cash flow of 30,000. Okay, and then we have to find its present value. So the interest is 7%. Okay, 7%, and the number of such values are 10. Okay, and then these are two separate values, 80,000 and 80,000. So 80,000 P over F, 7%, and it is at year 15, and then the other $80,000 is at year 20. Okay, so it is just now the matter of calculation. 30,000. So P over A is basically 1.07 power 10 minus 1, 0.07 into 1.07 power 10, and then this is 80,000 over 1.07 power 15, and plus 80,000 over 1.07 power 20. So let's open the calculator. So I have 30,000 multiplied by 1.07 power 10 minus 1 is this, and divided by 0.07 into 1.07 power 10, this one, equal to this. Then 80,000 divided by 1.07 power 15. Okay, so it is this value, and then 80,000 divided by 1.07 power 20, this value. So this value is 260,376. 260,376.65. So this is the present equivalent of all cash flows. So we need to find their annual equivalent, so we can use this value to convert it to annual value. Okay, so this to convert to change this value to the annual value. So this will be the we need to find the P into A over P, 7%, and then we will spread it for the whole life. Okay, 30 years, because the uniform the life of the bridge is 30 years. So okay, just input these values. 260,376.65 multiplied by 0.07 into 1.07 power 30 divided by 1.07 power 30 minus 1. Okay, so this, in this space I can put the answer in dollars. So calculate it. I have this value here before, multiplied by 0.07 multiplied by 1.07 power 30, that is equal to this, divided by 1.07 power 30 minus 1, that is equal to 20,982. So 20,982, and some decimal places 82 cent. So this is the annual uniform annual equivalent cost, which means that all these costs of $30,000 in the first 10 years, $80,000 in year 15, and $80,000 in 20 are equivalent to $20,982 per year, spread over this life of the bridge for 30 years. So 30 values of this $20,982. So these are equivalent, okay, to this. So this is the equivalent uniform annual cost or annual expense, whatever you say. So equivalent uniform annual expense, equivalent uniform annual expense or cost, it's the same.